Let's start. We have seen in the last class different types of statistics, and we have seen this hierarchy. We have done this left part, that is measure of central tendency, and we just need to look for measure of variability and how it is going to be used in our study. Anybody can tell me what is median? Middle value of the list. If the number of values are given in number, so what is the middle value? Adding two numbers of what?
So low and high values.
Low and high values in the middle. Okay. How about mod? Okay. Same repetition numbers are there. Which one will you consider? Same number of times, two numbers are repeating, two different numbers are repeating. First occurrence. Okay, let's look at the measure of variability once again. We will continue. Variability, as we understand, is a variation in the values. It's also known as a measure of dispersion. We understand the English meaning of dispersion. It is spreading across, and it is used to describe variability in a simple sample or a population of the data that you are considering to analyze. In statistics, there are three common measures or measurement parameters of variability. One is the range, one is variance, and we have dispersion. All right. What is range? It says it is given measure of how spread apart the values in the sample set or data set. What does that mean? Spread apart means what? It is from what point till what point in the number system it is going to be spread across. Like I have started from 0. So from 0, where you have went? From 0 to minus 2000 or from 0 to plus 4000? Where you want? What is your range? 0 to minus 2000. You went. That is my range. I am actually operating on that end. I have some numbers like minus 0.2, minus 5, minus 12, minus 1000, minus 1200. We have that. That's my range in the negative index or negative number. I also have one more range called 0 to 4000. I also have in that column that is having the numbers ranging from 0 to 4000. In between, it may be 2000, 2500, 2600, 26,000. So all those 24, 2400. So those kind of numbers are there. But what is the minimum number and what is the maximum number? In that will be my range of numbers. Alright? My minimum number is 0. Maximum number I have is 4000. That is my range of values that I have. Okay? That is how my measure of variability will show us they are varied from starting number till the end. That's what we are trying to understand. So what it says a given measure of how to spread apart values in a sample or population or a data set that you consider. The Excel sheets or CSV sheets that you are using in your programs is the data set itself. Okay, as you are doing your programs of finding out those measure of central tendency using those values, same way you can use those same data for finding out the range of the data set that you have. I hope you are getting a meaning of it. Got it? So if I ask you an example in terms of students in Karnataka have recently have taken good marks in SSLC. If I ask, what is the range of marks students have taken to pass? Then you say, okay, they started from the minimum marks until 625, right? Something? Yes, 25. So nobody has taken 625. So everybody has touched at 620. So what is my range from the minimum to the 620 is my range. So all the marks of 4 Karnataka students are spread across this range only. Okay. And in any subject, if people have taken the various marks, variations are there. But what is the range of variance that we have? From this marks, from 35 to 99, people have taken it. And somebody have taken 100 also. From 35 to 100 is one range of spreading the numbers. Okay. For example, 1 lakh students are there. 1 lakh numbers are there which are varying in different values. Got it? I hope you understand the range. How about, okay, you can find out with respect to this one. Range is equal to maximum value. For example, what is the minimum passing marks that you have to do for SSLC on minimum? Add together 35 into 6. 35 into 6 and 10. Okay. 210 is the minimum marks the student has to get to pass, just pass. And if I say 620 is the maximum marks of one student who is a complete topper for the Karnataka. Number 1, rank. So how about this formula? Maximum value 620 minus 210. Yes. So what will be the range? 410 is the range. So that's what you can find out. 410 is the range we have in this one only. The whole data has been taken. Do you understand what value they are giving? They are giving that 410. That means any number which is spreading across is having. Okay, they have these values itself. They have these many probable values. Like 410 values they can have. Somebody is having 211 till 620. Okay. How many numbers we have in the middle? There are 410. Alright. So these many numbers we have. This is the range where the numbers can possibly come in the column of how many marks the students have taken. Got it? And those who have failed, they have the range of 0 till 210. Alright? They have a different range. That's what they are trying to say. I hope you understood. Got it? That's got it. Next, variance. It simply describes or tell you how much a random variable differs. I hope you understand a random variable. Random variable which holds a number in a range but whose value is unpredictable. And what we are saying by taking that concept, it simply describes how much a random variable differs, or random variable's value differs from expected value. For example, if I give you the range of 1 to 10, I will be giving you like 1 to 6 in the dice. We have played a dice game. Okay, 1 to 6 numbers are there on each of case of a keyword. So range number of possible options that I can have on top will be definitely maximum 6. All right. How much? One possibly of the random value I'll be getting. All right. So I'll pick before you before you play the dice. I'll choose a number. I choose 4. So when I choose my 4, and now I play the dice. This is my random variable. This is my fixed value 4. All right. Now I'll check if I get 1, and I have already fixed my value 4. So I have a difference of 3 numbers. Get it? That's what it is saying. How my random variable is differing from the actual value that I am holding. I am holding a 4 and you are getting 1 and the max. Get it? That's what the difference it is trying to tell. Which property will tell that? Variance will tell that. Alright? Okay, let's see that. It simply describes how much random variable differs from expected value. And it is also computed as square of a deviation. Let's go back a little. GFG itself, it is good to go. Let's study the basic concept of statistics, that is standard deviation. As most of you have done this, those who are from those who completed 10th standard. All right. In statistics, the measure of variation of values is known as a standard deviation. Measure of variation or variance in the value, okay, is known as standard deviation. I hope you understand the meaning of this one. If you understand this, we'll go ahead. Variation of values. Okay, different values will be going to happen. That's what variation means. Variation of values. So when you see the variation, how do you measure the variation is happening or not? That will be measured. That will be measured with the help of the parameter called standard deviation. How much is variation? Got it? Okay. A low value of standard deviation says that the given set of values in Excel sheet is spread over a small range. Small variations happening. For example, I have given 1, 2, 3, 4. So one number is having 1, one number is having 4, one number is having 3, 2, 4, 3, 1. That much only. Small range, 1, 4. Few numbers are the only that variations happening. If I give the range of 1 to 10 lakh, huge number of variations. Okay? That is saying a low value of ST, that standard deviation, implies that means it describes or it implies that the given set of values is spread over a small range, whereas large value of SD as answer means that the set of values is spread out or spread out over a large range. What does that mean, large range? It is 1 to 10 lakh is the larger range. If you get a smaller value, a given set, if it is a low value, then you have a small range, like 1 to 4, small range. Alright, and I can also see the changes that are happening. First 1 is there, then 3 is there, or 4 is there. Again 1 is coming, 3 is coming, 2 is coming randomly. So changes are coming. But how many numbers? Maximum 4. If I give 1 to 10 lakh range, you can change any number. Get it? So less value of SD, that is a standard deviation, will tell you there is a small number of range are there. That's why we get the SD value small. If you're getting a larger value of the standard deviation, that means there are a huge number of variations that are happening. Get it? Alright? Okay. Standard deviation can be applied to the patients of blood pressure. Okay, where you see, if you see small standard deviation value, no problem, be happy. Large value of standard deviation, you have to think. Alright, and to be serious and just think about it, and you have to take care of it. It is going from 100 to 160, 180, 210, 250. Then there is standard deviation problem. You have a range of values starting from 120 by 80 to some 150 by 80 or 200 by 80. It's also low BP, then again you are doing 90 minus. Okay, that's standard deviation. You have to check, and you have a range of values. Get it? I hope you are getting now. Small standard deviation means small variation. 120 blood pressure. 130, no problem. Small variation, 120 to 30. That's how it says we have a small standard deviation will give us the small range implication or indication. Bigger value of standard deviation coming, then there is a large number of variations happening in terms of numbers. Okay, standard deviation is often represented by the Greek alphabet called sigma. All right, the sigma symbol. I hope all of you will remember. I hope all of you can see the symbol. I want you to remember the symbol. What is that? Yes. That's sigma symbol. All right. Whenever we use in the formula, you understand that it is standard deviation we are talking about. Got it? All right. Okay, alpha for a population standard deviation. Population standard deviation. What is this population now? It is the data that you are considering. The range of values that you are considering is the population. All right. So population standard deviation, or by the letter S, that is lowercase s, for the sample. Okay. That. Sample standard deviation for the S. Now we shall see what is the difference between a population and sample. The population is defined as the entire group you want to study on. The entire group you want to study on is the population. In simple words, that's all. You understand that?
Sir,
Example? Yes,
Yes,
please.
recently elections happened. Sir.
Election happened.
So 2 crore voters voted.
Totally over Karnataka.
That's
Okay.
how this number, sir. 2 crore
Okay.
people voted.
Okay.
So I want to
Analyze.
like to find the results sir, after exit polls. Sir. I
Right.
want to interview each and everybody.
Okay.
So this is the population is 2 crore voters. So
Okay.
if I want to find the exit polls, sir, I need to interview 2 crore people.
Correct.
And then I'll come with the 100% accurate result that as this many people of this group have voted for this party will win the elections. Okay. So that's a 2 crore is my population. But I can't go and interview each and every day.
Obviously, we cannot.
So what I decided to interview 2,000 people. Sir.
That's mine.
That's my sample. Sir.
Sample.
That is the sample of
2,000 people is sample. Few people will pick it. Okay.
That is the sample, sir.
Okay.
So I will interview those 2,000 people, and what is the result? Suppose 1,500 people have voted for a party out of 2,000. So I will come to the conclusion that so in this sample, this party will win. So I will apply the results of this sample to the population, entire population.
Yes.
Okay. So if in this sample, if this party can win, the same party will win in the population also.
Yes.
So this is what TV channels do.
Yes. That was the same. Here, for that, we have some rules to pick those samples. How do you pick those samples?
See,
Randomly, I cannot.
randomly I can't fix it
Hmm.
because if I interview 2,000 people in Hubli, so Hubli one party will win, sir.
Obviously.
But majority will have to find out the majority. I need to go across Karnataka. So the result of the Hubli, I can't normalize to entire Karnataka.
Obviously, we cannot.
So my sample results will be biased because of the limited geography. Sir.
Correct.
So to normalize it to entire population, sir. So 2,000 people I have to divide across the 224 constituencies.
Yes.
So I need to interview 50 people in each constituency or 10 people in each constituency.
Yes.
Then I will interview 2,224 people.
People spread across the Karnataka.
So out of this 2,000 people, if one party is getting a majority, then I can declare that party as the winner for entire Karnataka.
Yes. That's how it has to be done. Here also,
So again,
sampling.
in selecting the sample also, sir, we should not see that there are many factors which lead to bias in the sample, sir. So those biases I have to remove.
Yes. So we have in a formula parameter called bias.
Bias
Yes. In artificial intelligence and a neural network, specifically in a deep learning, you have parameter called bias that we do as you're saying.
Even just a normal routine example is cooking rice.
Okay.
The rice in the vessel itself is the population, sir.
Okay.
Whether it is prepared or not, I take one rice and test. That is the sample.
Yes, that's it.
So if
Understand. Well, Should not eat both cases. You keep one cake piece and just say whether it's sweet or not. Every Sunday there will be cake. Okay. All of you got it? Entire group you want to study is the whole group, we can say its population, and a part of population when we collect it, then we can say the measure or the sample. Okay, example, all football, Liverpool is not this one, I mean Indian context, it is internationally, it's a football club, Liverpool club, okay, all countries in the world, and in all countries in the world, all smartphone in the world is also one of them. A sample is defined as a subgroup of population under a specific condition. For example, all forward players in Liverpool Football Club will be one of the population. All countries that have existing monarchy, all smartphones made by Apple will be one group, one population. Population was a sample. This is the population, and these are the samples. Okay, there are a lot of symbols are there, figures are there. So we are just picking few of them. We just pick three: triangle, square, and pentagon. Regular polygons having 3, 4, 5, 6, 7, 8, 10, 12 sides. The sample size is usually less than population size. Do you agree? It is same concept of superset and subset. That's it. But in some rare cases, it can be the same size. Maximum it is same size. Now that we know difference between the population sample, let's look at the formula. Now standard deviation. I hope all of you can understand this formula. Root of variance. The root of variance of square. Square root of variance. Square root of variance. Okay, we have the variance. So what you told about the standard deviation parameters, and we'll come back to the formula later. Okay, here is sigma. That is my population of standard deviation. Then we have x of I. That is my ith observation. Ith observation. I don't know what is I, but this is my the observation number, and I have u. I mean that is mu, mean of n observation. What does it mean?
N is total number of observations. Capital N.
Average of
All the observations.
all the observations. So how many observations we have done? That's mean we are taking.
If you have taken marks for 10 students,
10 students.
average of all those students is the mean. N means capital N equal to 10.
What do you call this symbol? Mu only. N is the number of observations that we have done on the data. If xi has different probabilities, we use the formula like this. When n is being taken at, eliminated here. Xi has different probabilities. We can use this formula. Summation of I till from 1 to n. That's my range. And then probability will be including. Here we don't have probability. Okay. If the probability is different, then we used to be adding the probability there. Okay, let's keep it simple. Do not add that. Okay, so what you're trying to find out? Standard deviation. So what is that? Variations of variation of values. How many?
From the mean range.
Sample variation. Range of values. How much range? I to n. So that is my I equal to 1 till n. I don't know what is that n value, but I have defined. That means my starting point is 1. I will start from 1 and I may add 1000 or 10 lakh. That's up to me. That is n is now kept it open. You fill whatever number you want in the capital N. Alright? Okay. Next, so this is my range. We can understand this is my range of numbers that we have collected. Next, how about x of I? I observation. So what are you observing? I observation means x of I observation.
Here we are finding the average of the data elements. For example, 10 students marks we are taking.
Yes.
We have to find the average of all those 10.
Yes.
That will give your mu. That average is your mu.
Average is my mu. That is mean of n.
Mean of n.
Mean of n.
Average of 10 marks. All 10 students marks.
Yes. So that is my n value. That is number of observations that I have done.
That
For
is
example, I have. So n is my number of observations that I have done. So that values we have taken it. Here from I equal to 1 till n. N is the number of observations.
That is 10.
Yes.
N capital N equal to 10.
Capital N equal to 10.
Now you got the average of all those 10 marks. Now
Yes.
see that parenthesis brackets. Extra minus mu. You have to do this for each and all 10 observations.
10 observations. Yes.
First marks minus average square. Okay, in the sense, you got the means. That is the central value of the data. That's
Right.
where gravity of the data resides.
Right. But center value. Mid value.
Central values. So you have to find out each value how much it is far away from the mean.
Right. Right.
If the marks are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sum is 55. 55 by 10 is 5.5. So average is 5.5. Here in this data, sir, now you have to do 1 minus 5.5 square.
1 minus
5.5 square.
whole square.
So
Okay.
here you are getting the value that 1 is 4.5
1 is 4.5.
away from 5.5.
Right.
2 is 3.5 away from 5.5.
Right.
3 is 2.5 away from 5.5.
Right.
So they are measuring the distances.
Yes, measuring the
Each
distance is
value
wrong.
point, each data point, how much far away it is from the average.
Right. So can we take a small example here?
Yes.
Yes. So there is a problem of find the standard deviation of x equal to 2, 2, 3, 4, 6, 7 is the samples. I mean, the population given, that is x equal to, and you need to find out the standard deviation SD, that is the sigma. Now, what is n? 1, 2, 3, 4, 5, 6. 6 will be my n. This is my number of observations. Then, what is x is this one. X is having the same numbers. Mu that you are calculating. So, what is your mu? Where you find out the mu? Adding total. All the numbers you need to add. Okay, 2 plus 2, 4 plus 3, 7 plus 4, 11 plus 6, 17, 17 plus 7, 24 is divided by 24 divided by 1, 2, 3, 4, 5, 6. 24 divided by 6. 4. Okay, 4 will be my mu here. Alright. Then I have the calculation being done, and I need to find out the separate this thing, separately the formulas one part. Then we will be going to combine it and add it. So here we need to add, subtract x of I. I is starting from 1. So what is your 1? This is your 1. This is your 2, 3, 4, 5, 6 number. Then that is your I. X of I, that's first element is 2, taken up here, minus mu. What is your mu value? It is 4. That we just now found out with this calculation. 2 minus 4, and this whole square will be added here. That is my 2 minus 4 whole square. Same way, plus, why we are doing all the calculations? Because you added this one. That's why we are doing so many times calculations. If you remove that summation, I will do the calculation only once. Alright? Okay. So what the summation says? It says do the steps from I equal to 1 till n. What is n? 6 times. So summation says do 6 times. Alright? So 6 times you do it. This first time, second, third, fourth, fifth time, sixth time. So 6 times we will be going to do it. Simple? Alright. So these calculations will result in 20. Got it? Okay. Can you just check this calculation is right or not? Using Python, not calculator. Can you do it now? Do it quickly and just check. Only this much. X of I minus mu. Mu value is ready. Just do it and just check. We can find out the standard deviation, one part of that. Two minus 2 square. 2 minus 4, it's 2 square. Okay, 2 minus 4 is minus 2. 2 minus 4 is again minus 2. We have minus 1. We have 0. 6 minus 4, that is 2. 7 minus 4, that is 3 whole square. How do you do square in Python? How many? 2 stars? 2 plus. Okay, 2 stars. Right. Do it first. That's the equation. Done? 50. It's fast. Is that right? Yes. Right, right. Sir, it doesn't. That's what matters. Because you after 8 plus, people question. Okay. What do you know? It's not yeah, Q equal to 4 below that equal to done. Let's go. Here, okay, let's go ahead. We have got 22 as answer after subtracting and squaring it, square root of, taking the square of the numbers xi minus mu, which is a mean of n values. All right. Then we have 22 as the answer of your one of the calculation, and then the whole formula looks like this. The whole formula looks like this. Okay, this will be my full formula. So this value we already have kept ready. The numerator value is ready. We need to know what is the denominator value. What is the denominator value? N value, that is 6. So 22 you already got as an answer for the whole thing, this much, and you have to take a n in the denominator and do the calculation, divide that. What is it divide? 22 divided by 6. How much? 11 by 3. 11 by 3. Square root of 11 by 3. I think you have square root, you have everything. Math has square root. Square root of 22 by 6. You can import math, immediately do it, SQRT. Quickly. Square root of 22 by 6. 22 by 6. Is there? Import the math quickly. Import math. Math.sqrt. 22 by 6. Print the result fast. 9. The fraction has been rounded. You can use round and make the calculation, comma 2, 3, 9.4. Like this. Priya, look at this. Proceed. What is the answer? 1.914. Wait. Very fast. Plus 22 by 6 actually not. Can you see it's fast? Please, 1.7. All right, done. So the answer is 1.914. All right. I hope all of you have understood the formula and the bits and pieces of the formula. Got it? Okay. Now I have some questions. What is my xi?
2, 4, 2, 3, 4, 5.
All those numbers they are getting. Okay. How about this n value here? What it indicates on the separation top? Why you are writing it? Can I remove it? Is it needed or not needed? Why?
From initial point to sleep point.
Any element. How many elements we have? Those many elements it is giving us.
So it's like one summation sign.
Summation sign. Last end value, boundary value.
So it takes value from I to
N value. Okay. If I have 10 numbers, then we need 10.
Yes.
Okay. But
Counting the numbers.
counting the numbers, how many members are there? Okay. How about mu?
Average.
Average. That means add the 10 divided by 10. Okay. All 10 numbers will add it divided by 10. Average. Okay. So that's how we have the n value. So it is the number. Then okay. We know all the parameters now, so we can find out the square and the root of it, and we can do it. Okay. Now you are ready with the making it square root, and you also have ready with the making it square, right? Now I will give you the problem. You just need to tell me. You need to guide me to write the program. Okay, we'll take a sample data. So given data, I need n value. Initially, we'll take a samples. X equal to, I have the values like 10, 15. We'll take small values. Okay, these are the values. I need n value. Please tell me what is n value. Sure. Okay, pi is my n value. I got it. Next, I need a mu. How will I find average?
2 plus 1 plus 3.
All the things I need to find out. How can I find out the sum of all the numbers in the list? Should I use follow?
Yes.
Okay, I use follow.
Relative to the
Sum of
x. Sum of x.
Next.
Sum of x by capital X.
Capital N is there. Okay. Next.
That is the average.
I'm getting my average as 4.4. I'll just remember that. I'm getting 4.4 as my this value. I'll remove this. That's my P given here. What are things we need? Other things? This is enough. Everything is there. We do everything. We do it dynamically. Got it? Let's go ahead with the formula. We wanted to find sigma equal to. I need a square root. So what do I need to import? Import. Okay, can I do like this? From math, import sqrt, enough? Okay, then sqrt of, I'm ready with the sqrt. Now what is the formula? Inside that, what we need to do? We have two parts. Okay, let's take those two parts. We have like this. Alright. Inside this, we need to do something. For loop, we need to have for loop. Okay, we'll have the calculation and bring the result here. The calculation. We'll not have that directly. Okay, let's write the for loop first. For I in x is my number list. Okay, I have a colon. All right. Then
I minus u.
I'll take a sum, or what is my final value? That is my x minus u, right? X minus mu.
Yes.
X mu. I'll write it. Then I minus
It will be like 2 minus mu square. 5 minus mu complete the square.
we'll write one equation first, then we'll loop it. Okay, I minus mu is mu, capital mu. Okay, that is my calculation. So what is first number here in I? 2 is the number. What is my this value? It is fixed. That is my 4.4 is coming. So 2 minus 4.4. So after this, I need to have okay square root or square. So how do I do the square? This much is here. Okay, but I want to do the same process so many times, and I also want to add all of them. Like this. But it is with respect to I plus 1 and continuously I want to do it. But I cannot do all the plus and do it. Okay. Manually I can do it for 5 numbers. But when it is 1 lakh numbers, I cannot do like that. So I need to find a solution where I can add all the new values coming. Okay. So what I'll do is I'll ask my initial value, old value, to add to the new value. So I'll do like this. Okay. So I will define this value initially. Here I define this value as presently it is 0. So this is presently 0 plus this calculation. Then this 0 plus this calculation whole result will be stored in this one, which is having a new value, some value x, y, z. That value is available here in the next calculation, and it's new calculation, old value, new value calculation. Now together it is making a sum, giving a new value of the sum. Alright, that's all. Now the statement is automated. Alright, we don't want it to have like this, we want to have like this. We want it to come out of follow. Okay. before that, what I want to confirm is I just wanted to see what this value is printing. I want to print x mu. Let's print this. It's printing me 21.2. All right. Okay, I'm done with the calculation and it is available in this one. So what should I do with the next step? In the formula, where should I use that x minus mu? Insert this. Okay, this is my x underscore mu is ready, which is my 21.2. Got it? Okay, next I wanted to find out divided by n. I want to make as per my formula. I'll go back to my formula. Okay, this is my formula. xi minus u whole square divided by n. I have to do. I'm ready already with the square. Function is ready. Let's get back. Okay, are you ready with the answer? This is the answer. Okay, let's print the answer. Okay, that's my answer. So continuously it is printing all the values of this one. So it's going to give you the glimpse of how it is calculating each time. So initially it was 0, 5.7, then 6.38, 21.04, at last it is 21.2. And then we have this one, total calculation, then it's going to print the final answer, that is 2.059. Is that right? 1.9. 1.9. 1.9. You tell me those values. We'll get that same answer. Tell me that 2, 2, 2. Tell me that answers. Tell me the numbers. 6, 7. This much? Okay. You want this answer? This is a different answer then.
Yes, sir. 1.9.
We should get
1.9.
but we're not getting that. These the numbers are same.
Yes, sir. 2, 3, 4.
So what is n value? N value? How many elements are we have? 6 elements we have. So let's make 6. Okay. Let's expect the same answer. Program is ready. Whatever you put it, you get an answer. The algorithm is ready. Okay, now you just scan the program and see if you can understand everything. The formula, everything is clear. List you have taken, n we have taken as 6, count. Mu we are trying to find out sum of all the numbers divided by n. N is 6. We did use that. And we have taken this one with variable. We have initialized it to 0 so that you can use it in the equation here. And we use the for loop because continuously we want to pick one element, subtract it with the n value, and then here's the mu value. Mu value I have to subtract with each element. I'm taking 2 minus mu value under root. I want to square them and I want to add with the new value that is coming. So all the combinations I want to square it and add it. So that formula we have used it here. Dynamically it is adding and remembering the previous value that has been added, and also adding the previous value also. So that we are doing, and we are printing it continuously. If you don't want to print it, you can print it individually. Then we have the formula sigma equal to square root of x minus mu divided by n. That calculation is giving me the answer. So what is this answer is? What is the sigma answer? What do we call that? Standard deviation. It's D. Okay, standard deviation is this much. I hope all of you have understood how it is happening. Now we spoke about two things: low SD value, high SD value. Let us observe that place of 1.9148 with the changing values. Okay, we copy paste the same values two times, and let's see what is the difference. All right, means I'm doubling the range. All right. Any spell. Can you see the? Okay, we are not recording the previous value. Let's record the previous value first. It is same. It is 672 only.
Sir, I number 4 n equal to 6, sir. You give it n equal to ln of x.
Again, more automated. No? Okay, completely dynamic.
When you do plus change as
Nothing changed. Nothing changed. 542154. Even the last number also not changed. So they not changed.
Those initial set only, sir. Initial set of numbers only. Yes, sir.
Till here?
Yeah, exactly.
Okay.
Now I have the numbers, sir. 3 and 4, 6 and 7 replaced with 2 and 2, sir. Now this LD should come near to 1, sir.
Standard deviation should come
Near to 1, sir.
Come here to 1. Why?
Because the values are not varying much, sir.
Not
Values
varying
are
much.
almost similar. Here now, sir.
Okay, they are not deviating.
Yeah.
Yes, it is point something.
Yes.
If I write all ones, just a second.
Now it should be 0, I guess.
Any changes? No changes.
So all the values are similar, no deviation in the
No deviation means no variation. Let's make a small change. I'll make it 2. Small change. Okay. Small change. I'm making it 4. It's becoming more than that. And I'll add again one more 4. You can see again it is increasing with the fractions. I am reducing the number of values. I am making it 2. Now it is 0.4. I am going to reduce one more value. The number of values are less. We are getting 4, 7. I am only having two numbers. That's 0.5.
Sir, that's 0.5 because now you are at 2, sir.
Okay.
That total is nothing but 1 plus 1, sir.
1 plus
2 is nothing but 1 plus 1, sir. 1 comma 1 plus 1, sir.
Which one?
2, sir. 1 comma 2.
1, 2.
And 2 is nothing but 1 plus 1, sir. Now 1
plus
comma 1 is there.
Ah.
In the second part, 1 plus 1 is there, sir.
Okay.
This other part of the plus, sir, one more 1 is there.
Ah.
That you distribute across these 2 points. 1 and 1. So it will get 0.5, it will get 0.5. So both values become similar now. 1.5, 1.5.
Yes.
So that's 0.5 is the SDC.
Yes.
The extra part which you can share across all data points is the SDC.
Example.
घर में 4 बच्चे ओके अभी 3 बच्चे के प्लेट में इक्वल खाना है 4 बच्चे के टाइम में ज्यादा खाना पड़ा है तो माँ क्या करेगी जो ज्यादा जितना ज्यादा पड़ी है उसको लेके she will divide it across all plates.
Same example T.
हाँ T सर.
By 2. By 3. By 2.
जिसके कप में ज्यादा है वो ज्यादा जो है मिला है उसको सभी में डिस्ट्रीब्यूट.
हाँ मतलब
जिसको ज्यादा मिला है जितना ज्यादा मिला है वो ज्यादा को सभी में बांटना है.
Correct.
That is yes.
Understood? Take it by 2 by 3. Okay, 3 people are there. 2 tea are 2 cups are there. 3 people have to share. Right? Okay. Yes, sir. What if I make it only 1 hour?
It will be 0 only, sir.
This, because there is no variation. No
If
variation.
you get second number as 2, then it is deviating by 1 part.
One point one is varying. Increment. 1 1 minus 1 0. Correct. How about 3? Same calculation. You just do it in mind. What is length? Length is 2. So n is 2. Sum 4 by n 2. 4 by 2 2. Mu is 2. 1 by 1 minus 1 minus 2 minus 1 whole square. Square. It is continuously you do that for 2 times. You'll be getting how much you'll be getting? I minus how much you'll be getting? I minus mu. What is square of 1?
1.
Okay, then we'll be going to print this whole thing is become 2, as you can print here. Then we have this x minus 2 will become 2, so this is 2 divided by n is 2 divided by 2. How much is 2 divided by 2? 1. Square root of 1. So answer is 1. Alright, so there is no, there's very less variation that you can have. How do I increase the variation?
Make 3 to 5 cents.
3, 2, 5. Odd numbers?
Any numbers
Any numbers.
or make 1 minus 2.
Minus 2. It's waiting in the.
This first one you can make it minus 2.
Minus 2 is the starting number. More numbers? Minus 2 then? Raise. Minus 1. Then 1. Lower. 8. It's 7:30, not 8. Huh? Harish is very curious about numbers. Yes, it is 3.6. All right. So it's 79 and data 3.6. So as you are increasing the number, increasing the standard deviation, the variation in the numbers is more. It is indicating. That's the prime task of why we are using the standard deviation. I hope we are very clear with the standard deviation. All right. Whenever we use the standard deviation, we will be able to recognize what it is. That's why we have spent much time onto this one. I hope all of you are comfortable with the standard deviation. It simply describes a random variable differs from expected value, and it is also computed as a square of deviation. All right. What we said, it is also computed as a square of deviation. So whenever you make a square of deviation, you get a variance. Means how much it varies, so that will be told to you with the help of square of deviation. In this formula, n represents the total data points, x bar represents the mean of the data points, or the mu of the data points, xi represents the individual data points. Individual means the numbers are taken. Okay, xi. That's how this formula that we saw will show you the standard deviation, and to that you can make a square of it. I hope we are clear with the calculation and the program. Dispersion, it measures the dispersion of a set of data from its mean. I want all of you to the variance and the dispersion using the sample data of everyone. All right, we already have the program ready. I'll close this one. Use the same program, practice this one, and bring me the variance version values. All right. Okay. We are touching all the points which are there. If I just go, this is only one slide we have spent so much time, but all the words that we have taken in future, when I just read it, it will its definition and everything is already there in my mind. I can go fast. That's why I'm building the dictionary of the module in your mind first. Whenever I talk those words, those meanings, I want to create it. Alright? Else you will not get any interest. Even I will not be getting interest. Alright? So that's why let's focus on each words. Let's learn that way. I hope I am clear with the what you are doing. Alright? Okay. I hope you are clear with the assignment. Any questions? Alright, then we stop here today. Thank you for joining, all of you. Thank you.